Okay, so this is an escape velocity equation or example. Here's our escape velocity equation. The velocity, the escape velocity from an object of mass m, and from the r is the distance from the center of that object. So in this particular version, the mass has to be in kilograms. The distance from the center of that object, which is often just simply the radius of the, if it's a planet, for example, but it doesn't have to be the radius. It's just the distance from the center of the object m that you're trying to escape from, has to be in meters. So the mass has to be in kilograms, and the radius has to be in kilometers. Here's our, and then of course it has this factor of 2g in the numerator. Here's our universal gravitational constant, 6.67 times 10 to the minus 11th. Of course, I didn't put the units, as I often don't in class. The reason for that, of course, is that if everything else is in the proper units, then those are the correct units for, or the correct numerical value for big G. The escape velocity will ultimately be in meters per second. So let's do this example. Let's start out with a mass of 8.2 times 10 to the 25th kilograms. Let's say that you started out with you're given in the problem that something that was trying to escape from this planet, let's say a rocket or something like that, is 9.4 times 10 to the third kilometers from the center. Often the distances will be given in kilometers, and we have to, of course, convert that from kilometers to meters. All right, so I've already done it here. I just want to go through what I did. You know that, of course, there's 1,000 meters in a kilometer. So we set up our fraction with the conversion such that whatever we're trying to convert cancels. So in this case, the 1 kilometer goes in the denominator, the 10 to the third meters goes in the numerator, the kilometers cancel, and so and also remember 10 to the third times 10 to the third. You have the same base, so you simply add the exponents. Up here, I've already put these numbers, these numerical values in, and let's now use our calculator to figure out what the answer is. Okay. All right. So hopefully you can see that. I'm going to do the square root at the very end, so I'm going to go 2 times 6.67. Remember to use your exponential notation, however your calculator uses it. This one I have to do Shift EE to the minus 11th. Remember, you don't use the minus sign per se. You use the negative button on your case. You got to figure out where that is on your calculator. Times the mass 8.2, Shift EE, times 10 to the 25th, and then we divide by let's see, what is it, 9.4 times 10 to the 6th. Okay, remember, this is not the answer. This is before we take the square root. Another thing is, when you notice when I hit answer, this numerical value is way greater than the speed of light. You're not going to have any escape velocity that is going to exceed the speed of light. So anyhow, that's just a little trick to remember during the tests. If you come up with an escape velocity that's greater than the speed of light and you're not talking about a black hole, then you probably didn't go far enough. So what do we have to do here? I already have a square root button on this calculator, so I'm going to take the square root of the answer, and there is our escape velocity. So it's 34,113, and of course that would be meters per second. All right, and let's see, I think I wrote it down here. I did this problem a little earlier. So there, of course, is the escape velocity. All right.